Okay, for 7.1, we are starting a new unit on exponents. And specifically for lesson 7.1, we're looking at zero exponents and negative exponents. So to begin with, I'd like for you guys to look at this looking at patterns box right here. 2 to the anything power, 2 to the fourth, 2 to the third, 2 to the second, 2 to the first, 2 to the 0 power, 2 to the -1 and -2 power. So 2 to the x, what would these answers be? 2 to the fourth power, remember, means 2 times 2 times 2 times 2. You can also, by the way, put it in your calculator by doing 2, and then this little caret key to the power of means we're using an exponent. So I'm going to push to the power of 4. So 2 to the power of 4 equals 16, which is 2 times 2 times 2 times 2. So that would be 16. Let's fill this all in. 2 to the third power is 2 times 2 times 2, which is 8. 2 times 2, 2 squared is 4. 2 to the first power, if there's only one 2, then it's just 2. Let's look at the pattern we have. We went 16, we cut it in half to 8, we cut it in half to 4, we cut it in half to 2. If we cut this in half as well, 2 to the 0 power is going to be 1. So when we're recording this, when we're writing it down, it's 2 to the 0 power, and anything to the 0 power is 1. I really want you to circle that or put a star by it or something, because what I need you to know is anything raised to the power of 0 is going to be 1. It doesn't matter what the base number is. If it's raised to the power of 0, it is a 1. Okay, if we cut it in half again, because let's look at our pattern. All of these get cut in half. 1 cut in half is half. So that is going to be correct. 2 to the -1 power is going to be a fraction, 0.5, which is the same thing as 1/2. So the little trick is I put the base number on the bottom, and there's only one of them because it's to the first power, negative first power. So 2 to the -2, I'm going to cut half in half again. So that's going to be 1/4. And if you weren't sure, you could either use your calculator, or to see that it's 1/4, which is 0.25, or 2 squared, I want you to know it's the same thing as if it flips to the bottom under a 1. So this whole thing becomes positive and flips to the bottom under a 1. So that would be 1/4. Okay, let's do the same thing with to the powers of 10. 10 to the fourth power is 10 times 10 times 10 times 10. Or it's a 1 and 1, 2, 3, 4 zeros. So 10 to the fourth power, 10,000. All right. 10 to the third power is going to have 3 zeros. 10 to the second power is going to have 2 zeros. 10 to the first power is just 10. See what we're doing here? We're cutting off a 0 each time. So 10 to the 0 power is just going to be 1, because like I told you here, anything to the 0 power is 1. It doesn't matter what the base is. If it's to the 0 power, it's 1. Okay, let's do our trick here. 10 to the 1 is going to flip in a fraction to the bottom. 1 over 10 to the first is just 1 over 10 to the first, but you don't even need a little 1. You can leave it invisible. 10 to the -2 is 1 over 10 to the now it's positive 2 when it flips to the bottom. And 10 squared, we can go ahead and answer. 10 squared is 100. So it's technically 1 over 100. So this pattern's just going to keep getting smaller and smaller the greater the negative we go. Okay, we have learned today 0 and negative exponents. So the 0 ones I had you guys kind of put a star by, and the negative ones, I know those are new, but they're not difficult. It just flips to the bottom under a fraction with the numerator being 1, and then it's positive. So 10 to the -2 becomes 10 to the +2 on the bottom under a 1. All right, so we can do this. So 4 to the 0 is 1. Anything to the 0, -3 to the 0 is 1. Any weird decimal even to the 0 is 1. If you have a negative, it flips to the bottom and becomes positive under a 1. If you have a negative exponent, it flips to the bottom and the exponent, remember, becomes positive. if the base is negative, the base is going to stay negative. But the exponent is going to become positive when it flips to the bottom under a 1. I also want you to see that a variable, a to the 0 power, is also 1. Anything, any number or letter to the 0 power is 1. Any variable to the negative power can flip to the bottom and become that variable to the now positive power under a 1. Okay, so why can't you use 0 as a base? So we can't use 0 as a base because 0 to the third is 0, 0 squared is 0, 0 to the first is 0, 0 to the 0 is 0. Like 0 ends up being 0, so it's undefined. So we're not going to use 0 as a base. You can use 0 as an exponent like we did right here, but it only works when the base number is not 0. So we're not going to use 0 as a base. It would be undefined. However, any other number to the 0 power would equal 1. Okay, oh, yes, except not that one, because 0 to the 0 power is undefined. Okay, so let's go ahead and try some of these. 9 to the negative 2 is going to flip under a 1 and become 9 to the positive 2. I would go ahead and have you simplify this out because you can tell me what 9 squared is. 9 squared is 9 times 9, which is 81. So 1 over 81. Anything to the 0 power is 1. I love those. They're so easy. Okay, I would like for you to pause the video and try these 5 got it's just to check and see if you're understanding what they are. Okay, if you are moving on and want to check your answer, or maybe you're not sure you did the right answer, I can work these out with you. 1 over, get rid of that negative, and it would be 4 to the now positive third. If you went ahead and simplified that, 4 to the third is 64. So this would be 1 over 64. Anything to the 0 power is 1. 3 to the negative 2 is going to be 1 over 3 to the positive 2. And 3 to the positive 2 is 9, so 1/9. Can't have a negative exponent, so it's going to flip to the bottom and become positive. And remember, anything to the power of 1 is just itself. So we're just going to call this 1/6. All right, can't have a negative exponent, so it's going to flip to the bottom, but the base is going to stay negative. The base is going to still be a negative 4, but now when you move it to the denominator, the exponent becomes positive. So we can go ahead and work that out. Negative 4 squared is negative 4 times negative 4, which is positive 16. Okay, what is the simplified form of this expression? Let's try this now. Individual terms. We have to decide what to do with the 5. There's really nothing we can do with the 5, so I'm going to leave it 5. There's really nothing I can do to the a to the third, so I'm going to leave it a to the third. But we learned that you cannot have a negative exponent. So if you have a b to the negative second, it would flip to the bottom under a 1 and become b to the positive second, but we have all this other stuff here. So it's like we still have 5a to the third up here. So times 1, because if it's all squished together on the numerator, we're assuming they're being multiplied. So we can, 1 times anything is just the anything. So anytime you have a b to the negative second, it's going to flip to the bottom under what was already there. So we are going to leave 5a to the third in the numerator, because technically this is all over a hidden invisible 1. This would all be over 1, because if you told me, for example, 2 is the same thing as 2 over 1. So any term can be written as itself over 1. So technically this whole term was a hidden invisible 1 on the bottom, but now we're going to take this b to the negative 2 and put it on the bottom. And once it goes to the denominator, the exponent becomes positive, because if it's a negative exponent, it's going to flip to the denominator and it's going to become positive. Okay, let's try another one like that. If it happens to be a negative on the bottom, here's how to get rid of it. You move it to the numerator. So let me go over here and review. If it's a negative on the numerator, it goes to the denominator and becomes positive. If it's a negative on the denominator, it moves to the numerator and becomes positive. And this is technically over 1. It was actually times 1 because the 1 that was on the top is there, but it's hidden and visible, so you can leave it off. And anything over 1 is just itself. Same thing I did up here with the 2. Anything over 1 is just the same thing as whatever that whole number was. So if it's on the top over a 1, you can just call it x to the 5th. Okay, let's look at page 2 of these notes. This is a got it section. I would love for you to pause the video and try these 5 on your own if you're ready, if you can. If you are maybe not ready to move on to try these on your own, I can work them out with you, or if you're checking your answers, x to the negative 9 is going to flip to the bottom under a 1 and become x to the, now it's a positive 9. N to the negative 3 on the denominator needs to flip to the numerator and become n to the positive 3. Technically, yes, this is over a 1, but you don't need that because anything over 1 is just itself. It's a little blurry. I'm going to see if I can get that. Oh, there we go. That looks a little better. Okay, anytime you have multiple terms, you need to look at them individually. So the whole thing is not negative. Only the c to the negative third is. So 4 is doing just fine on its own, staying in the numerator. So we're going to leave 4 where it's at. B is also totally fine where it's at. There's nothing wrong with B. So we're going to leave B next to 4. But the c to the negative third needs to flip down to the denominator. So we're going to put it down here, and now it's going to become positive. So this is your simplified answer here. On D, 2 is absolutely fine. Leave 2 in the numerator. It can stay there. But the a to the negative third cannot. So it needs to move up and join the 2. So it's now going to be 2a to the positive third. And yes, this whole thing is in the numerator. It's technically over 1. But anytime it's over 1, you can just leave it as a whole number. And it looks like this n to the negative 5 is going to have to flip to the denominator. And when it flips to the denominator and becomes positive, it's going to join the m squared that was already there. And you cannot leave a fraction with an empty numerator. You can't leave it with nothing on the top. So you're going to fill that with a hidden invisible 1. So the final answer here is actually 1 over m squared n to the 5th. And by the way, anytime you have multiple variables, like if you have m, n, p, q, whatever, you need to put them in alphabetic order. That's just how you will see it in algebra. So if the n would have come alphabetically before m, I would have put n to the 5th m squared. But m comes before n, so this is correct. Okay, the next section is now we're going to actually have a final answer because now I know what s is. It's 2. And now I know what t is. It's negative 3. So we're going to change these to being the numbers that they represent and then solve it to get a final answer. So I would probably write 3 times, remember s is 2, 2 to the third power times t is now negative 3. I'm going to put it in parentheses to the negative second power. So we can solve these. 3 I'm just going to break down as just 3. 2 to the third, I'm going to go ahead and use my calculator and say 2 to the third power is 8. And then I'm going to use my calculator, and don't forget your parentheses. It will give you the wrong answer if you do not use parentheses. Negative 3 to the negative second power. Oh, that's going to be a fraction. So let me just work this out a different way instead of my calculator. Negative exponent is going to flip to the bottom under a whatever's up there. It would be a 1, but we've got some other stuff up there. And negative 3 is going to stay negative, but the exponent, when it flips to the denominator, is going to become positive now. So let's break this down. Let me get rid of that. Let's break this down a little more. 3 times 8 is 24. Negative 3 times itself squared, negative 3 times negative 3 is positive 9. And those can simplify. They can both divide evenly by 3, I believe. So that's going to simplify to 8/3. And you could leave it 8/3. It's going to be a weird fraction if you don't. So 8/3 is totally fine. Okay. You're going to do a few of these. Let's not do all 5 because I think once you do a few of these, you're going to get the hang of it. Let's do A and C on this. So since it's a got it, go ahead and push pause. You're going to use -2 for N and 5 for W and see if you can solve A and C on your own. If you're not ready to do it on your own, let me work it out with you. N is -2. So this is -2 to the -4th power. W to the 0, I'm just going to remind you that anything to the 0 power is 1. So this whole thing times 1 is just going to be whatever this whole thing is. So you don't even really need it. Anytime I see something to the 0 power, I just cross it off. Unless it's in the numerator like this one is, and you can fill that in with a 1, you really don't need it because anything times 1 is just whatever the anything is. So I just need to solve this. 2 to the -4th is going to flip to the denominator and become 1 over -2 to the, now it's going to be a +4th. So I can go ahead and work that out. -2 to the 4th power, parenthesis, -2 to the 4th power is 16. -2 times -2 times -2 times -2 is +16. Okay, for C, N to the 0, anything to the 0 is 1 over W to the 6th, and remember W is 5. So we've got 1 over 5 to the 6th power. 5 to the 6th power is 15,625. 15,625. Okay. The last section is just a word problem. This is actually all worked out for you, but I want to just kind of explain what they did really quickly. A population of marine bacteria doubles every hour, which is why it's 2 to the power of H. H represents the number of hours. So it wants you to evaluate the expression at 0 hours and at -3 hours. So anytime you have it to the 0 power, that's just going to be 1. So 1,000 times 1 would have just been 1,000. And then if you plugged in -3, they worked it out for you right here. They had 1,000 times, they flipped this under a 1 and made it 2 to the +3, which is 8. And then in their calculator, probably they did 1,000 times 1/8, which is 125. So if I gave you a problem very similar to this, like for the got it, it says a population of insects triples every week. The number of insects is modeled by the expression 5,400 times 3 to the power of W, where W is weeks. So evaluate the expression when there's been -2 weeks, 0 weeks, and 1 week. What would each one be? Since this is a got it, you can go ahead and push pause and try it on your own. Okay, so we are doing 5,400 times 3 to our first W value, which is -2. That would be 5,400 times 1 over 3 to the +2, which 3 to the +2 is 9. So our first initial answer is 5,400 times 1 ABC 9, which is how you do 1/9 in my calculator, and that is 600. So the first value is 600. The next one would be 5,400 times 3 to the power of 0. Well, we know anything to the power of 0 is just 1, but 5,400 times 1 is just 5,400. And then our third answer, 5,400 times 3 to the power of 1, well, that would just be 5,400 times 3, because 3 to the power of 1 is itself. So that would be 5,400 times 3, 16,200. 16,200.